Ever since elementary school and middle school, you've been talking about states of matter in school. Today, I really expect that you'd be able to describe the states of matter in terms of energy, particle motion, and phase transitions. You have a lot of previous knowledge about this stuff, so I'm not going to go over a lot of that in detail. For instance, you know that a solid looks like that gem there. You know that a liquid can be pourable, although that's liquid mercury, not liquid water. And you know that a gas looks something like this diffuse air or vapor. That's nitrogen dioxide gas, which is actually a major component in air pollution in the summer. You know, those hot, sunny days when the air's all hazy? Well, that's that stuff. All right, you need to know solids have definite shape and volume, liquids flow, gases take the shape and volume of the container, and a vapor is really just the gaseous form of something that's normally a liquid. So, for instance, water, when water is a gas, we call it water vapor. Why? Because it's normally a liquid, but since it does form a gas when it evaporates, that's why we call it a vapor, because it really should be a liquid. Solids will do the same thing. Vicks VapoRub, maybe. All right, you need this whole table. Notice that solids and liquids are much more similar to each other than liquids and gases. We talked about the kinetic molecular theory in class. This is the ping pong ball jar. We know that matter is made of tiny particles, that kinetic energy is the same thing as temperature, is the same thing as particle speed. Well, that's a simplification. It's not the same, but it's pretty close. So that means if something has low temperature, it has low particle speed, it has low kinetic energy. If something has a high temperature, it has high particle speed, it has high kinetic energy. All right, there is a lowest possible temperature. It's absolute zero. That's when the particles stop moving. Well, they almost stop. And that's when particle speed, we know particle speed will determine the space between the particles. If particles are moving really fast, it's probably going to be a gas. If particles are moving really slow, it's probably going to be a solid. All right, just like these pictures. So these are static pictures. The particles aren't actually moving, but imagine that they're moving. Gas particles would be moving fast and they're far apart. Liquid would be moving medium speed, but they're still really close together. And solid is very close and they're moving slow, but they are moving. They're vibrating in place. All right, what determines the state? Why is this ice cube a solid and this glass of liquid water a liquid, even though they're both H2O, they're both water? Well, this one should be pretty obvious. It's because of the temperature. The ice has to be colder than the water. But what about this situation? That's a balloon of oxygen gas. That's a few bars of gold. I wish I had those, but these things are at the same temperature. So why is the oxygen a gas and why is the gold a solid, even though the particles are moving at the same speed or almost the same speed? That seems a little more confusing. What the heck's going on here? Well, it's actually something called intermolecular forces. It's because the oxygen particles don't stick together. They don't have really an attraction towards each other, and the gold particles do. So even though the gold particles are moving at the same speed as the oxygen, the gold particles aren't moving fast enough to break their stickiness, but the oxygen are. The oxygen aren't sticking at all, so they're just flying around everywhere, and that's why it's a gas. That's a gray seal. Kind of cute, right? All right, so temperatures and intermolecular forces determine state. Intermolecular forces are attractions between the particles in a substance. It depends on the shape and bonding of the atoms in that substance. So again, this is the stickiness between particles. Sometimes some substances are very sticky. Some substances aren't very sticky. Nitrogen isn't sticky. Oxygen isn't sticky. Helium is very not sticky. Helium is going to be a gas until you cool it down really, really far because it just barely sticks. By the way, the non-sticky stuff usually has induced dipole forces. You don't have to worry about that term. Gold, on the other hand, and other metals are usually high intermolecular forces because of metallic bonding. You don't need to know what metallic bonding is. But that's why, even at the same temperature, if you're in the same room, you can have a solid, liquid, and gas all existing next to each other at exactly the same temperature because just the substances in them have different intermolecular forces. This ends up being really important for the idea of phase changes. For instance, why is it that if you put a glass of water out on the counter, all the water molecules, the liquid water, will all turn to gas? But if you put an empty glass on the counter, it won't fill with water molecules that are already in the air. That seems like, why does one happen, not the other? Same thing. You put an ice cube tray in the freezer, it has ice cubes all in it. If you wait 2 months, those ice cubes will shrink and shrink and shrink. And the reason they do that is they actually sublime. Solid ice, solid water molecules will actually turn into a gas on their own. But gaseous water won't really turn back into a solid in the ice cube tray in the same way. So if you put an empty ice cube tray in the freezer, you won't get nice ice cubes after a few months, ever. You might get some really nasty frost, but that's not in the nice little wells of the ice cube tray. All right, this is actually one of the fundamental laws of the universe. It's called the law of the second law of thermodynamics. Entropy is the trend towards disorder. It's the natural tendency for a system to become more and more disordered. So think about this in the context of your room at home. If you don't put work and energy into cleaning your room, it gradually turns into a mess, right? Next time your mom and dad says, clean your room, why does your room get so messy? You can say to them, my room gets messy because of the second law of thermodynamics, which says everything tends toward disorder. So it's the same rule that says why an empty glass put out on the counter won't get liquid water in it from the air so easily. All right, you need to know that that means that solids are most likely to sublime and liquids evaporate and gases diffuse, because gases are the most disordered form of matter. Solids are all in one place. They're pretty ordered.